And it's recording. All right, here we go. So we're in term 3 now. We're on exercise 5C. And I'm just going to delete these notes so that we can start fresh. Delete these notes so you can't see. And I'll delete these notes so that you can't see. All right, let's start right here. So far, you've learnt what is an expression. You learnt terms. So let's have a look at what I wrote down here. So when we use pronumerals, there are expressions. Now, what is a pronumeral again? Hands up if you, someone explain to me. What's a pronumeral? Oh, no one knows? Well, you're too shy. Let me just pick someone. Let's go with Zara. Zara S. What's a pronumeral? Represents or a number. It's a variable that represents a number. Can you write here, for those who don't know what pronumeral means, it's a letter that represents a number. And just in case you're listening to what I'm saying but you don't understand what I mean, you already did this in primary school, and logically you sort of get it as well. Remember back in primary school you do something like this, magic squares? Yeah. So magic square plus 3 equals 7, for example. What's a magic square? 4. So what you already intuitively learnt in primary school is that box represents a number. Yeah, you've learnt that this picture, this empty spot, is a number. Well, instead of using shapes, you see shapes, there's only so many shapes you can draw. You can draw a square, rectangle, maybe a triangle, and a circle. There's only 4 or 5 that you can come up with. But the letter system, the alphabet system, we have 26 of them. That's why we use letters. Yeah. So instead of doing magic square plus 3 equals 7, we then do something like A plus 3 equals 7. It means the same thing. See, A is a letter that represents a number, just like the magic square was a shape that represents a number. So if you can understand that, that's what a pronumeral is. Okay. So this is the beginnings of what we call algebra. But technically, you had already started since primary school. You were doing algebra in primary school. You just didn't call it algebra. This is the ability to think, what if I don't know what the number is? How do I figure it out? Okay? So pronumeral is a letter that represents a number. These are expressions. So here is an expression. How many terms in this expression? I'm revising exercise 5A here. So how many terms in this expression that I've given as an example? Yes, Eknor. There are 6. Let's count them. It's always separated by a plus or minus sign. So here we go. 1, separated by a plus sign. 2, separated by a plus sign. 3, separated plus. 4, separated plus. 5, separated plus 6. So yes, there are 6 terms. So if you weren't here for exercise 5A, that's what it means when I say how many terms does this expression have? There are 6 of them. Okay, now out of those 6, so you got A, and you got B and a B, we have what we call like terms. Okay, so these are all terms. There's 6 terms, but not all of them are the same. Now, I can see 2 different types of terms. What 2 different types of terms can you see? Let's go with Hamza. What 2 different types of terms can you see there? A and B. This is the A group. Those are my A's. These are my B's. So they're obviously different. It's like talking about apples and bananas, hypothetically. I normally don't like teaching algebra, thinking of fruits, but in this way, it might make it more sense to you. If I asked you right now, I've got A plus A plus A plus A. Think of A as an apple. So I've got an apple plus an apple plus an apple plus an apple. How many apples do I have? 4 apples. So logically, you all knew that, right? We didn't even have to write the number 1 in front of A to say that's 1A plus 1A plus 1A plus 1A to make it 4A. You knew it just by looking at the letter. So that's why in mathematics we say, well, if we add them, I can say that there are 4 apples in total, and then how many, let's say B is bananas. How many bananas do you have? 2. So then here we have 2 bananas. But does it make sense to add the 2 together and say 4 plus 2 is 6 apple bananas? No. Because they're 2 different fruits, true? Because if you have apples, you got 4 apples and then you've got 2 bananas, it doesn't make sense to tell someone you've got 6 apple bananas. People are like, what does that mean? So you have 4 apples is 4 apples. 2 bananas is 2 bananas. They're different groups. So today's lesson, this is what you're doing. You're practicing to identify which groups are the same that you can make smaller, and then which other groups are the same that you can make smaller. That's called simplifying. So here, right on the side, I want you to understand the word. When we say simplify, so S-I-M-P-L-I-F-Y, that's what it means by simplify. Because if I gave you a choice, listening, if I gave you a choice right now, do you prefer writing the first line in your exercise book, or do you prefer writing the second line? First line or the second line? First line. Oh, wow. Okay. Well, not many people prefer writing A plus A plus A plus A, especially if I wrote this. If I told Attila to write 19A plus 200B, I'm sure Attila would still not, this time, prefer to do option A, option 1. Because option 1 takes too long to write. That's why when we say simplify, we're saying, let's make it easier for ourselves. Instead of writing 19 of these A's, that's too many, plus 200 of these B's, isn't it just easier to write 19A and 20B? Yeah, so that's called simplifying. So today's lesson, you're practicing, 1, to count the number of terms, and out of those terms, which ones are the same terms? And then you add or subtract them. Okay, so you group the ones that are the same, and that's called collecting like terms. Okay, so today's lesson is you're trying to simplify, which means you're doing this, that bit. Okay, so let's do the first example. Let's have a look at this one. Let's jump to this one for a bit, and then I'll come back to that ABC thing. Let's look at this. So this expression, this is called an expression, not an equation, because it doesn't have equal signs. So this is an expression. How many terms are there in this expression? Let's go with Attila.
4.
Oh, not 4. Separated by plus or a minus sign. So here's my plus sign, here's my plus sign. So how many terms do you see? 3. So this is 1 term. This is 2 terms. This is 3 terms. Okay, so this is exercise 5A revising. How do you know how many terms? Look for the plus minus signs. It separates them. Yeah? So I've got 3 terms there. But out of those 3 terms, are there any terms that are the same?
Yes.
Which 2?
3A and 2A.
Very good. Can you see that this is an A, this is an A? Now you might say, but Mr. Tran, this has an A as well. I'm like, yeah, it does, but it also has a B. So if we're talking about apples, hypothetically, there are many different types of apples. This might be your red apples. And then with a B onto it, it might be like an apple with a bruise. Apple that's bruised, hypothetically, right? So you can't say that they're the same. You've got 2 nice red apples, and then here you've got an apple that is bruised. They're not the same. Okay, so the letters, the pronumerals, they have to be exactly the same. So when you have an A, you look for any other groups that have just an A. Okay, then you can count them together. So in this case, these 2, yes, they are like terms. They have the same exact letter. So that means I've got 3 of these A's plus 2 of these A's. How many A's do I have if I simplify it? How many A's would I get? 5. Very good. Because I got 3 A's plus 2 A's. So if you think of it as like apples, 3 apples plus 2 apples. How many apples do you have? 5 apples. Does that make sense? Write that down. Write that down so that you're familiar with what I'm doing there. So we're looking for, out of the 3 terms, which one are the same? And notice that, yes, all 3 have an A, but only these 2 have just 1 A. That's why we can group those 2 together. 3 plus 2 we can group together as 3A plus 2A gives me a total of 5A. And then over here, plus 4AB, remember these 2 are not the same groups. One is an apple and one is a bruised apple. They're not the same. So you can't say I've got 9 apples or 9 bruised apples because it's not true. I only got 4 bruised apples and 5 good apples. Yeah? So that's why you can't group it together. Any student who does this is wrong. Because now you're saying something different. You're saying you've got 9 of these bruised apples, which is not true. I got clearly 4. And then apples itself, I only got 5 of them. So that's your answer. Out of the 2 expressions, this is a longer expression. People can't be bothered writing 3a plus 2a plus 4ab. They prefer writing 5a plus 4ab because there's only 2 terms there. Yeah, can you see there's only 2? 1, 2, separated by a plus or a minus sign. So 2 is better than writing 3. Yeah? But what I also like is for you to also understand, why can you add 3a and plus 2a? Let's take a step a bit further, okay? So underneath, I'm going to show you the logic. When you say 3a plus 2a plus 4ab, let's revise what you learnt in exercise 5a. When you write the number 3 next to an a, what's happening in between it again? Are you adding, subtracting, multiplying, or dividing? Timesing, very good. Now, if I put a times in between them all, so it's actually 3 times a, 2 times a, 4 times a times b. What does 3 times a truly mean? 3 a's. So if you break it down, this actually means a plus a plus a, because that's what 3 a's mean. True? A plus a plus a is 3 groups of a. I've got 3 of them. Then, what does it say here? It says plus, you're adding now 2 groups of a. What's 2 groups of a look like? 2 a's, yeah. It'll be a plus a. And then, here's another plus. And now you're saying 4 groups of AB. What does 4 groups of AB look like? Yeah, it's 4 of them. So if you write it out, this is 1 AB plus 2 ABs plus 3 ABs plus 4 ABs. That's what that actually means. When you say 4AB, you're actually thinking this. Now, if you look at that expression, that's a very long expression. No one can be bothered writing that. Yeah? This is why in mathematics, because we can't be bothered writing that long line, that's so long. Some of you probably didn't even copy it down because you're like, oh my God, it's too much. But because of that, we learn to simplify. You see, if you're adding them all together, which ones are the same? Which ones are the same? Clearly, this is AB, 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 AB. Only these ones are the same. A plus A plus A plus A plus A. Those are the only ones that are the same. That's why you can say, well, together, how many A's do I have? 5 of those A's, or 5 groups of A's, plus, exactly. That's why you can't group them together. You can't say 9AB. Doesn't make sense. Because that's their group. That's the AB group, and that's the A group. They're 2 totally different groups. Okay, so if you're sort of understanding what I'm saying, well done. That's the skill I'm trying to teach you today. So today's exercise is about you understanding, yes, A represents a number. So a letter represents a number, but then every letter is a different number. So you have to choose the right groups. Okay? Let's do the next one. Let's go back up here. All right. Now we're talking about A's, B's, and C's. Let's have a look at this. I just revised with you exercise 5A. So what's in between A, B, and C? Are you adding, subtracting, multiplying, or dividing? Multiplying. So this actually means A times B times C. Versus CBA actually means C times B times A. Now, a lot of students, when I first ask them, and I say, is A times B times C equal to C times B times A? A lot of students would likely say, what do you think they would say? Oh, wow. Yes would be smart. No is the common answer. A lot of students think that the order matters when it's timesing. It doesn't. See, in the example, if I told you A was 1, B was 2, and C was 3, what is 1 times 2 times 3 equal to? 6. Very good, because 1 times 2 is 2, and then 2 times 3 is 6. But then if I swap the orders around, if C is 3, and B I said was 2 before, and then A was 1, so even if you swap the order, 3 times 2 is 6, and then 6 times 1 is still 6. So that means when you do with algebra, it actually doesn't matter about the order. You can write A, B, C, or you can write C, B, A. What's another way can you write it? What's another way? Yeah, very good. You can write B, C, A. And it means exactly the same thing. Or back, yes. Or you can write B, A, C. They all mean the same thing because B times A times C or C times B times A, they're all going to equal. So, why am I showing you this? The reason why is because I can swap the letters and you're meant to know that they're exactly the same groups to group them together. Here's an example. Let's do this example. Can you see how I swap the letters? Yeah. See here, how many terms are there? 3. 3, very good. So this time you got it, Attila. So plus, there's 1, 2, 3 terms there. Out of those 3, which ones are the same? Now a lot of students look at it and go, oh, nothing's the same. Because one's CD, the other one's DC, and the other one's C squared D. But actually, CD means C times D. But then DC is just the swapped order. D times C is the same thing as C times D. So even though they're in different order, it actually is still the same. Just like ABC or BAC, the order doesn't matter. The fact is that do you have one C and a one D? In this case, I do have one C and I have a one D. So that's why they are the same groups. Those two are the same. That's why you can actually write it like this now. You can write it, if it helps you to visualize, you can write it as 2CD plus, and if the DC is confusing you, just convert it. Right? 4CD. There's nothing wrong. You can swap the order yourself. Absolutely fine to swap the order. Whereas this one, yes, they have a C and a D, but what's different about this group and the other two groups? That's right. This has a square, so that's why it's different. Yeah, just like you guys, we've got different students here. Even though you're about the same age, you're all different. There's something different about each one of you. Just like the letters, just because you have a C doesn't mean you're the same. There's a square on one of them and the other one doesn't have it. So they're not the same. Yeah? So here, let's put it together. I don't want to write 2CD plus 4CD plus 6C squared D. There has to be a shorter way. I can group these two together because they are the same groups. So what is 2CD plus 4CD? 6CD. Beautiful. 6CD plus 6C squared D. And you cannot add these two together. They're two different groups. One is a CD and the other one is a C squared D. They're two different groups. You can't group them together to say, I've got 12 of these. Because it's not true. Yeah, they're two different groups. So far, so good? How's that feel? That's exercise 5C. So all they do in exercise 5C is they're going to swap it around. They put a negative. They're going to put like many letters and many squares. But the theory is the same. The theory is you're looking for groups that are the same. Here's the last one. Why don't you try this last one? How many terms are there? Sorry, this one should have been up here. I'm just going to rewrite it again. Let's just write it as minus y(x squared). How many terms are there? Beautiful. Love it. You just came and you're doing well. There we go. Plus, plus, minus. There are 1, 2, 3, 4. Out of those 4, there has to be something that you can group together. There are 2 that's the same. Now, I want you to have a go. I'm going to time you. It's currently 2:24. I'm going to time you for, let's go at 90 seconds, so a minute and a half. I want you to simplify this. Instead of writing 4 terms, we can actually make it down to 2 terms. Okay? Simplify that for me. Starting now. Let's go. 90 seconds. Find me which 2 terms can you group it together. Because there's obviously something that's the same. I'm going to pause the video. Let's just check your process. Here we go. First step. Look for the same groups. Now this one has an X, 1X, 1Y. Which other one has 1X, 1Y? Which other one? Which other one? Very good. This one has 1X, 1Y. This one doesn't. That one actually has an X squared and a Y, so this one's different. That's X squared Y. And this one is also X squared Y. So the one I highlight in yellow is grouped together, and the one I highlighted in blue, you group together. So if you add them, now notice, I know the order is different here, but remember we said the order doesn't matter. So you can actually write it as xy plus 2xy, so those two are the same, plus, notice this is x squared y, so you got 2x squared y, and then you minus, and you can swap the order if you want to make it easier for you. You can swap the order. It's okay to swap the order. Okay, so then now you've got x squared y, x squared y and x squared y. So let's calculate it. What is xy plus 2xy? 3xy, because xy, that's one group of these xy's, and you're adding another 2. That gives you 3xy plus, now how many of these x squared y's do you have? You start off with 2 and you minus 1. You get? What do you get? How many x squared y's? 1. Very good, Xavier. So you can see 2 minus 1. 2 minus 1 of them should only give you 1 of these x squared y's left over. You can't add those two together because they're different groups. One's an x squared y and the other one is an xy. So you can't add them together. That's it. That's your answer. Your answer is 3xy plus x squared y. Can I get a show of hands? Out of those 3, do you feel, let's say, about at least 80% confident? Hands up if you feel 80% confident you understood what I was saying. 80% or higher. All right? What about 70% confident or higher? All right, that's not bad. That's most of you. Yeah, that means they're from, okay, so it's about 70 and above. Very good. That's what I want you to practice right now, okay? And then after you've got some practice in you, we'll then do a problem-solving question together, okay? So you can do problem-solving once you understand how to add the grouping like terms. So can you turn to your textbook or refer to the one on the board here? This is the exercise I want you to do. Here we go. I'm going to pause the video. All right, it's recording. So we're now going to do an example of a problem-solving type question. Let's have a look. You've got a rectangle. You've got a rectangle here. It says write expressions. So it means that it wants you to write an algebra answer for the perimeter of the following shape. Now I've got a rectangle. This is a rectangle. Now the longer side, what do we call the long side of a rectangle? What's the name? Length. So let's call this length. So length is equal to 6x. Okay, so that means 6 times x. So we don't know what x is. It's a number. It's 6 times that number. Yeah? What is the shorter side called again? Width. So write that in. Write width is equal to 3x. Now perimeter. Back in primary school in year 7, and I think we haven't done measurements yet in year 8, but how do you find the perimeter? What does the perimeter mean? What's the perimeter? Anyone remember? Ryan, what's the perimeter mean? Outside length. Very good. Perimeter means if you had to walk around the shape, how far would you have traveled? Now, if you think about it, if you started here, on the top left corner, if you have to walk around the shape, you'd have to walk, let's go down 3x, then you have to go across 6x, and then you have to go back up 3x again. So you have to go back up, and then you have to walk all the way back to return back to the same spot. That's called a perimeter. Okay? So if you had to work out the perimeter, it would actually be equal to the width, because that's how far you traveled, width, plus length, plus W again, plus length again. Okay, now, well, it's very good. You guys are all doing the calculations. Very good. So if we put it all together, we said W, the width, is equal to 3x. Length was 6x. Width again is 3x. Plus L again, which is 6x. Notice they all are like terms. They all have an x. So if you add them all together, you're right. 6 plus 6 plus 3 plus 3 gives you 18x. Now, in mathematics, we're too lazy to write the word perimeter as well, so we usually use letter P for perimeter. So that is what we call an expression. Okay, so if I want to find the perimeter, it's 18x, or 18 times x. The problem is we don't know what x is. X is an unknown number. That's why you can't solve it, you can't evaluate it, it's just an expression. That's why in the next part of the question, they say, well, what if x is 2? If x is 2, what would the length and the width of the rectangle be? So if x is 2, so length, we said length was equal to 6x. Width, we said it was equal to 3x. So if x equals 2, what would my length equal to? Can I please have Yu-Chen? If x equals 2 and length is 6x, then what would my length equal to? 12, because 6x means 6 times x, but if x is 2, then 6 times 2 tells you 12, whatever units it is. So it doesn't tell us units, so we don't know if it's 12 centimeters or 12 meters or 12 kilometers, so we just say 12 units for now. So 12 units. What about the width? What would the width equal to? Let's go with Josh. So width is 3x, but if x was 2, then... Say that again? Yes, that is correct, because it's 3x means 3 times x, but x is 2, so 3 times 2 is 6. So the answer is 6 units. What would the perimeter be, though? So I'm just adding another question now. What would the perimeter be? Now, some students might do the long way. They might do 12 plus 12 plus 6 plus 6. So they did length plus w plus w. Well, what's a shorter way? What's a shorter way? Instead of doing 12 plus 12 plus 6 plus 6 or 24 plus 12, what's a shorter way? Yes, that's usually how you do it, but there was a reason why we did part A first. Why was this special?
Double it.
Yeah. Because remember, you did the whole simplifying. The whole point of simplifying is so you don't do that step that you would just describe. Instead of doing 12 plus 12 plus 6 plus 6, you simplified it already. Your perimeter was equal to 18x. So 18x just means 18 times whatever x is. Since x is 2, you double it. What's double of 18?
36.
36. You see the benefit of using algebra to simplify your expression. You then don't waste time doing it over and over again. Yeah? So that's the benefit of why we simplify expressions. Instead of writing 3x plus 6x plus 3x plus 6x, we realize that it's actually just 18x. So as soon as you know what x is, you can actually work out the length, the perimeter, and the width. That's the benefit of the ability to write expressions. Yeah? And another conceptual thinking is, why can't x be negative 2? What's the problem if x is negative 2? Why doesn't this work? I mean, I can sub it in. I can put negative 2, so length would be 6 times negative 2, it's negative 12. Width would be 3 times negative 2, which is negative 6. And perimeter would be 18 times negative 2, which is negative 36. Why is it a problem? Someone explain to me. Why can't x be negative 2? Because we said x can be any number. We said x could be 2, but why can't it be negative 2? Any reasoning? Ryan?
Because it doesn't make sense to like a negative length.
Yeah. See, on a logical basis, if I asked you to draw a rectangle and I said, I want you to draw me negative 12 centimeters and negative 6 centimeters, where are you going to do that? How are you going to do that on a ruler? The ruler is always 0, positive 1, positive 2, positive 3. It doesn't make sense to even rule negative 2 centimeters. Yeah. So the logic here is, this is called the application and reasoning that my year 11s and 12s generally struggle with. It's the idea that, yes, they are numbers, but in an application, do you understand what those numbers represent? So here, the reason why it can't be negative 2, is because length doesn't make sense to be negative. To be negative. Those kind of questions are the reasoning questions to think about. Okay, so this one here doesn't make sense to have negative 12 length, width to be negative 12, or even the perimeter to be negative. It just doesn't make sense. Yeah? Money does make sense. Money, if you have negative, it means you owe money. Yeah? Positive money means you got more money. It's credit. So you have to think about the situation like time. You can't have negative time. It doesn't make sense. Time keeps going. You can never go backwards in time. Yeah? All right, team. So that's application that you can see it's a bit different. You still use the skills, but you have to apply in the situation. So that's what you're doing if you're doing problem-solving questions, or if you're just working on fluency, which is usually 2 to 6. Yeah, 2 to 6 is your fluency. Ideally, I want you to eventually work towards problem-solving, then reasoning, then enrichment, but you got to challenge yourself. Okay, so find where you're sitting at. Minimum is fluency. Okay, so for each exercise, you have to be able to demonstrate logical understanding, or at least regurgitate the technique. Yeah? So I'm going to stop there. That's the video, and you've got 15 minutes or 16 minutes left of your time. Happy to come around to clarify anything, but that's it for